are doing today graphing lines in y equals mx plus b. We're throwing it all the way back to y equals mx plus b form, which is also noted as slope and y-intercept form. So if you ever see something saying like graph the line or write the line in slope-intercept form, it just means y equals mx plus b, right? Where if you want to like denote your colors and you take your highlighters, M is your slope, so that's like your rise over run. Like how much are you increasing by or how much are you decreasing by? Versus B, which I'll do in blue, that is your initial value. That's like your y-intercept, right? So a lot of people use that as like the starting point for graphing a line and then do rise over run from that point, right? So for example, just easy little walk in the park. It's already in y equals mx plus b form, so I don't have to do much. But it's saying, can I graph it? So already, I should probably be able to identify what's my m, what's my b, which in this case, what is my m? 2. Thank you. M is my 2. This is my slope. And then what's my b? -1. Right? So the sign does matter in front. That's your y-intercept. Right? Slope, I'll remind you, that is your rise over run. Which when you have a whole number, it just means you're gonna go up by that much, so 2, and then just over 1. Right? So that's it. So in this case, I'm gonna go to my starting point, which is -1, which is right here on my graph. And I'm gonna do my rise over run. So I'm going up 2, over 1, up 2, over 1. And I'm just gonna repeat for how much space I've got. Up 2, over 1, up 2, over 1. And then I can even go backwards and extend it this way.
Isn't it -1 though? Wouldn't it go the other way?
That's our y-intercept, is our -1, which is here.
Oh.
So I was gonna follow up by saying, how do you know which way to go versus going this way versus, for example, if I were to do something that looks like this, we read lines left to right, right? So for example, this is increasing. If I'm looking at it left to right, I can see I'm going up, right? I would never read it backwards being like, oh, I'm going down this way. Always left to right, so you are increasing. Versus if it were -2, then I would have started at -1 and I would have gone down to over 1, down to over 1 to make it go like that. Right, so always think about it left to right. Was that okay? That was okay so far? Cool. That's all it is. You just have to get to your initial point and then count your rise over run. That's all. If you've got a line that's not in slope-intercept form, which is the other form of standard form, which looks like this in this yellow here, ax plus by plus c, where a, b, and c are just constants or like their coefficients, their whole numbers in front, we gotta then take that format and we gotta rearrange it because I can't tell what the slope is by looking at something like example 2. I have no clue what my y-intercept is. That doesn't tell me anything. So it'd probably be helpful if I could rearrange this to slope y-intercept form and then be able to graph. It's okay. If I want that, the goal is y needs to be by itself. So how could I put y by itself? What's got to move? What's got to get kicked over? Jack, you're going to make me yawn. What's getting moved over? I agree. -4 and x. Okay, this is getting kicked over and we're going to change its sign. And same thing, x is getting kicked over, and we're gonna change its sign. So, okay, now I've just got 2y is equal to -x plus 4. Okay, I've got y by itself, but I don't have like y exactly. I've got 2y. So my last step is I need to get rid of that 2. And we said if it's attached by multiplication, the only way to undo it is what? Division, right? We gotta divide it. So I'm gonna divide both sides by 2. Right? So cancel out here, and now y is officially by itself. And now you'll notice, okay, if I go to do -x over 2, that's like saying -1x over 2. I can't really simplify that. I just have to keep it as -1/2 x. Right? And then same thing. Can I do 4 over 2? Does that simplify? Yeah, what does that simplify to? 2. Just 2. Voila, so it's like I took each term and just divided it by 2. Now it's in y equals mx plus b mode, where what is my m? What's my b? What's my m in this case, or my slope? This is my m, -1/2. Which if I want to write it as like rise over run, so that I know like what I'm going up and over by, it's like I'm going down 1/2, right? Down because it's negative, and then over 2 always. And then what's my b? What's my starting point? 2, exactly. So that's your y-intercept. So okay, I'm gonna take this over to the chart, and I'm gonna say, okay, 2 is up here, this is gonna be my starting point. And then here's where I'm doing rise over run. So because it's a negative slope, I'm gonna be decreasing, right? Left to right, I'm going over to the right. So I'm gonna go down 1/2, down 1/2, down 1/2, and then just keep repeating. And you'll see you can extend the line this way. So this is gonna be our line, which try your best to make it straight. What? What's up? You got the direction?
Yeah.
Cool. And that's it. So if it's not in y equals mx plus b form, the goal should be put it in y equals mx plus b form. Because then that tells you all the information you need to graph it. Standard didn't tell me anything, right? So that's why it's valuable to switch forms. Not bad, right? Cool. I'm okay to flip, or are we still copying? Is there any questions? Anything you want to clarify? No? Okay. Flip. So we're still graphing, but now it's saying, can we graph a line using x and y intercepts? The intercepts just mean where is it crossing the x-axis? Where is it crossing the y-axis? Where is it touching those like big bold black lines there that are labeled as x and y? So for example, it gave us this. It said determine the x and y intercepts of this line, and it's in standard form, and we want to graph it. So we could do one of two methods. We could try switching this to y equals mx plus b, but I've got some big numbers, so meh, what's the point? Or I could think about what is happening at the x and y intercept. So for example, with 1, if I'm trying to find the x-intercept, or AKA, when am I crossing like this horizontal line, like right here, that black line, I'm looking for when y is equal to 0, right? If I'm touching this line here, my y value is 0, right? This is 0, 0, so I haven't gone up or down. I'm just here. So x-intercept is when y is 0, so I'm gonna just plug in 0 into that equation there. So here's my equation. I've got 4x plus 6y, but instead of writing y, I'm just going to replace it with 0 equals 48. What is 6 times 0? 0. So it's eliminated.
Oh,
Gone.
great.
Right? So now I just got 4x equals 48. I can easily find what x is now. What do I got to do?
Divide.
Divide. Thank you, Jack. Which follow-up? What is 48 divided by 4? Spoke too soon.
Is
Well, 48
Oh, it's
divided by
12, it's
2.
12, it's 12, it's 12.
You could even break it down of like, okay, 48 divided by 2 is 24, and then divided by 2 again is 12. So exactly, at 12. So I know my x-intercept is going to be 12. And then if at the x-intercept y was 0, what do you think is happening at the y-intercept? X is 0, exactly. So they take turns being 0. So I'm gonna just do the same exact thing, but now I'm gonna just replace x with 0 instead of y with 0, like last time. So again, 4, and then instead of x, I'm saying 0 plus 6y equals 48. And guess what? 4 times 0, 0. So it's just gone. We don't have to worry about it. We're only left with 6y equals 48. Which then if we wanna find y, we're just dividing both sides by 6. Which, okay, what does that leave us with? Y is equal to what? 8. Voila. So those are your x and y intercepts, right? If you wanted to then graph this line, you can go plot those points. So for example, at this one, this graph, I don't think it really fit. I would change these numbers to, instead of going by 2s, I would change these to 4s. So try and write like over it, 4, 8, 12, 16, and same thing. This scale's not quite that pretty. Negative 12, negative 16. And then I think our 2s are fine. No, I do the same thing. 4, 8, 12, and negative 4, and negative 8. Okay, from there to graph those, I'm just gonna see, okay, x equals 12. I'm going on the x-axis, and I'm plotting at 12. So, okay, that's my first point. And then same thing for y, I'm going to 8 on the y-axis. And because I've got those 2 points, now I'm just going to connect them. So this is where a ruler would be helpful to just connect these points. Ooh. See, even my iPad didn't do it quite right. There you go. That's a little straighter. If you want to get into more exactness of a line, you could then rearrange to y equals mx plus b and determine like the exact slope to do rise over run. But if we're just using the x-intercepts and the y-intercept, that's more than enough. Determine what each one are and then connect. Solid. Is that okay? Anything you want to run through one more time with this, or is this okay? This is cool? Okay. Whereas horizontal and vertical lines, I see this in grade 11. Some of my kids are like, what does this look like? And we actually did this yesterday. They looked at lines that looked like this, and they kind of got confused and tripped up, and they forgot it from grade 10. But there are things that are like lines, for example, that don't have slope, right? Either they're just flat like this, or they're straight up like this. So which one is which? If we want to do, for example, y equals 5, that just means for whatever x value, it's always going to just produce an output value of 5. So at 1, it's going to be 5. At 2, it's going to be 5. At 3, it's going to be 5. So you're going to see that y equals 5 is just a horizontal line through 5. This is y equals 5. Right? Because we said at any point, no matter what the x value is, it's just going to produce a y value of 5. The y value is not changing at all. Right? 4, 5, and so on and so forth.
Doesn't it say x equals minus 5 instead of, oh shoot, never mind.
That's another one that we're going to look at. So that's y equals 5. If I do, for example, in blue, the one that Jack was just talking about, x equals negative 5, that just means no matter what my x value is, or sorry, the x value will stay the same, but my y value could change. So for example, negative 5, 1, negative 5, 2, negative 5, 3. You're seeing that my negative 5 is consistent. It's not changing. That's my only x value. So you'll see it's going to produce the vertical line. Is your pencil sharp or what?
Yeah. Alright, man.
Ooh, that's at positive 5.
Wait, isn't it minus 5?
Yes, it is. I just noticed that at negative 5. There we are. X equals negative 5, which I'll re-highlight in case you need help seeing it a little darker.
Do you have to write the 1, 5, 2, 5, 3, 5?
No, that's just me writing that for you, just so that you can see that no matter what, like your other coordinate will not change, right? So for example, with the pink one where y was equal to 5, it didn't matter what my x value was. Either way, y was going to be 5. So that's why it produces that horizontal line. Versus with blue, with x, my x value stayed the same no matter what the y value was. So that's why it makes the vertical line. Sometimes people trip these up because they think of horizontal lines associating with x, since x is like the horizontal axis, right? So they would do it the flip way. And they would say, oh, the pink one would be x is equal to 5, because that's like going this way across the x-axis. But no. Think about which value you're intersecting. Like for this one, you're going through x is equal to negative 5. I realize that this one's on negative 6, so just give it a little scooch over. I realize that. I thought that was a 5. So you're going through that x value. Same thing with pink. You're going through that y value. That's not an x value. That's a y. All right, so here. I'm doing my little 1 over. Okay. Is that okay, the idea of horizontal and vertical lines? In the flip. It takes practice. But think about which value you're intersecting on which axis. Yeah, Hanifa. On mine, I've got it going by 2. So -2, -4, and then I had it on -6. So that's why. Okay. Am I good to flip, or are we okay with these? Like, do we want to go over these? Thumbs up? Solid. Okay. Peeps, are we good?
Yeah.
Don't worry, we're flying through these reviews, so you'll have more than enough time to chat with your friends, right? But these are gonna be in Unit 1. This is gonna be on our first unit test too, so these are good things to know. The last thing that we're just talking about, Eamon and Will, the last thing that we're talking about is parallel and perpendicular lines, as well as like points of intersection. So, do you remember what parallel lines are? Yeah, Jack.
I have a question.
Yeah?
It's about like the days before tests and like unit tests.
Mm-hmm.
Will we like get a review packet or will it be on the
No, I'm not giving you anything. Of course I'm gonna give you stuff. Yes, of course. We're gonna have review packages. We'll do a review period where we spend the entire class.
At least more than 2 days in advance.
Sure.
thing?
Is that okay?
Yeah.
Is that enough time? No, okay,
2 days would be good.
I wasn't gonna give you okay, I don't wanna give it too far in advance, because I don't wanna overwhelm you with things, especially if we still have stuff to learn.
But at least we have it. We can go home and review.
Yeah, I could give it to you on the day of the last lesson, so then you have that day, the work period, and then test. Is that enough? Cool. Okay, now that that's out of the way, what parallel lines? What are they?
I'll answer that, but just quickly, my game got moved to 1:30.
A 130? Okay.
A parallel line is
They don't touch. They don't meet.
two lines that will never intersect on the left.
Exactly. They're the forbidden lovers of math. They're just going like this forever for infinity. They're never going to cross. They're never going to touch. It's so sad. So they have the same slope. Right? Okay, friends. Thank you. Right? Parallel lines got the same slope. So for example, if it's asking you to find a line that's parallel to this line where it's given to you in standard form, the goal should be I need to find a line with the same slope. Can I tell in standard form what the hell the slope is for that? No, so I should probably rearrange it first. So step 1, rearrange to y equals mx plus b. Because then at least I can see what the slope is and know, okay, it's got to be the same thing as that. So, okay, if we've got 2x plus y minus 5. Goal is y needs to be by itself, so everything else is getting the boot. It's getting kicked over. So this is going to be y equals, and everything flips signs when we change it over. So this is going to be minus 2x plus 5. Is that okay? That's the first time I did it without the arrows.
Wait, I just messed up.
Jack and Fetty, what you looking at? Yeah, no, he's not peering over, right? Remember, week 1's still probationary. It's dying to be used, the Cell Hotel. Right? So is this okay? This is the first time I didn't do arrows to show things moving over, but this was okay, knowing that the 2x flipped sign and the -5 flipped sign, because we
Yeah.
brought it over. Cool. What's my slope here?
Negative.
0 is
Yeah.
just 0. I don't have to say 5 plus 0, because that's just nothing.
Wait, I have a
It just is
question.
gone.
Well, you don't need to write plus 0. It's just saying plus nothing.
Okay.
Yeah, so it's just meaning the 0 means nothing was on that side before, versus now I've brought things over. There are things on that side now.
I have a question.
Yeah.
So with the first one, it said y equals minus 5, but then you didn't put the 5 over to the other side, so why is it plus 5 now?
I did move it.
Yeah, she did.
But why is it, it can't be because the y is by itself now.
Yeah, that's the goal. We're trying to put it into y equals mx plus b form. So that's why we said, okay, I got a plus 5 on both sides, and I got a minus 2x.
Do people ever write it 2x plus 5 equals y? Do people ever do that?
Yeah, it doesn't matter which side you want to put y on.
Oh, I got it
They're
now. I
equivalent.
understand it.
Got it? So what's my slope of this line? What's the slope? Positive 2 or negative 2?
Negative 2.
-2.
That will make the difference.
Good for you, Jack.
Right? So my slope is negative 2. So if I'm writing a line that's parallel to this, I know it also has to have a slope of negative 2. Right? So, but how will I know? So input
So it goes down 2 and then goes 5 to the right.
No, 5 would be our starting point for that line, but then our slope is just -2, so it'd be going down 2 over 1, down 2 over 1.
Is it always?
Wait, is it because X is gone?
It's because that's a whole number. Anytime you have a whole number, you're gonna go over 1, over
Oh,
1.
yeah.
right? Versus if it's like a fraction, like 2 over 3, then it's like you're going down 2 over 3, down 2 over 3. Whole numbers, it's just over 1. Okay, so here's my line. I know it's got to have a slope of -2, but I'm kind of stuck here because how am I supposed to figure out the y-intercept of this line? This question did give me some information. It told me that it specifically has to go through this point. Okay, are we following? Right? You good? Do you want me to clarify something?
No, it's fine.
No? Cool. So I was saying, I don't know if you heard me, but if we input that slope, because we're saying, okay, if these two lines are parallel, they have the same slope. So if I take y equals mx plus b and I just input a slope of -2, I'm kind of stuck here because I'm like, how am I supposed to find b? How am I supposed to know what the y-intercept of this parallel line is? The question told me that this parallel line specifically has to go through this point A. So I'm going to use that. This is an x value. This is a y value. If I plug those in for x and y in that equation, I can solve for b. So we're going to plug in point A.
Don't you know B?
We don't know b,
It says right there that it's.
but that's the one line. That's our original line that we're starting with.
Second line?
We're finding a second line that's parallel to it. Exactly.
Should we write like beside it like one, first line, we line?
Sure, if you want to call it like line 1. So plug in point A. So, okay, instead of saying y, I'm going to replace y with 5, since that's my y coordinate of point A. And I'm going to do the same thing for x. -2 times my x coordinate is -1 plus b. Look at that. Now I only have b missing. -2 times -1, what's that? What's that going to give me? 2 negatives make a
Positive.
positive, so that's going to be +2. And now I want b by itself, so what do I got to do with that 2?
Divide by 2.
Mm,
Wait.
look at the operation happening. It's attached by addition, so opposite of addition is subtraction. So 5 minus 2 is b, which is 3. So therefore, we can say the line parallel to, and then you can put it either back in standard form, the one there, or we'll say that. We'll say 2x plus y minus 5 is, and we can say y equals, and we found it, -2x plus 3. Because that was our slope, and that was our y-intercept.
I have a question. What does the
We-
3 dots mean? Like, number in?
You've never seen the 3 dots before?
I just forgot.
It means therefore. It's like a shorter, fancier way.
Okay.
Therefore, the line parallel to that line is -2x plus 3. So the goal is like, find out what the slope is, because you got to make it the same slope. And then once you know the slope, use the point that you're given in the equation to use as x and y so that you can find your intercept. And then that's your line. Right? Same thing is happening for perpendicular lines, but what are perpendicular lines? We said parallel lines, they've got the same slope and they're running alongside each other. But it says here, 2 parallel lines are negative reciprocals. What does that even mean? What is a negative reciprocal? And what are perpendicular lines? What do they look like? How do they intersect? Do we remember? Or do we need a refresher? Yeah, Luke?
So like if you have a slope of 4, negative reciprocal would be -1.
-1/4. So Luke's saying we got to change the sign and flip it. And why we do that is because perpendicular lines meet like this. They are meeting at exactly 90 degrees. They're perfectly crossing each other like that. So a negative reciprocal means whatever your slope is, let's say your slope is m, or we'll say like n, then your negative reciprocal slope is going to be -1/n, where I'm just saying n is like a number. So you're going to change the sign and you're going to make it a fraction. You're going to flip it. Right? We're going to practice this. So same thing. They give us one in standard form. I can't tell what the slope is. I can't tell what the y-intercept is. I should probably rearrange this. And it gave me a specific point that I have to cross through. So step 1, always rearrange to y equals mx plus b. Which, okay, if I've got 4x minus 2y plus 6 equals 0, my goal is I want y by itself. So who's getting the boot? What do I want to move over? What should I move? Okay, so I can subtract 4x from both sides, and I can subtract the 6 to move them over and cancel them out. So I'm left with negative 2y is equal to negative 4x minus 6. But I need y, just y. So what's my last step that I gotta do? I gotta divide by negative 2. Whatever's attached to the y, divide it out. So okay, y will be equal to negative 4 divided by negative 2, which negative divided by negative makes a positive. So this is really like 4 divided by 2, which is what? Just 2. And then what about negative 6 divided by negative 2? Positive 3. 12 will be multiplying. That's okay. So, okay, what's my slope of this line? Okay, so my regular slope is 2, which means my negative reciprocal slope, which we use this little denotion of like this upside down looking T. It just means like that's the slope where it's gonna like meet at a 90-degree angle, right? I'm going to change the sign, so it's gonna go from positive to negative, and I'm gonna flip it to a fraction. So the negative reciprocal slope is gonna be negative 1 over 2. Do we see that? Even if I'm just doing on the board, like here, if I give you practice, what if I told you m is 3 over 4? What would the negative reciprocal slope be? Negative what? Negative 4 over 3. If I gave you m was negative 1 over 5, what would the reciprocal slope be? 5 over 1, or just 5. If I gave you m is equal to negative 10 over 7, what would the reciprocal slope be? What? 7 over 10. Thank you, Freddie, for being the only one to answer. Thank you. Right, so you're just flipping it and change the sign. If it starts as a negative slope, the reciprocal will be a positive. If the original is positive, the reciprocal will be negative. And if it's a fraction, see how you're just flipping. You're just making the top and the bottom switch places. If it's a fraction, you'll notice, like for example, 1 over 5, this just simplifies to 5. Same thing if you have like, if the original is 1 over 2, the reciprocal is going to be negative 2 over 1, or just negative 2. Right, so you'll notice if you've got a 1 here, it's going to make a positive number or a whole number. There we go. So, okay, I know for the perpendicular line, it's got to have that perpendicular slope. So 3. So I got to use y equals mx plus b. So input m equals negative 1/2 into y equals mx plus b. But then this is where I get stuck again, where I'm like, okay, I don't know what my y-intercept is. I don't know what the b is for this line. So I got to use my point, my information that it gave me in the question, telling me specifically I have to cross through this point. Right? Is there anything you want me to clarify? I hear chat. Is there things you want me to clarify? Because I hear people like talking in small groups. Tell me.
It was just telling me why I need the reciprocal.
Why? Because it's a perpendicular line. That's why. So that's why it's got to have that crossing slope. Perfect. So again, this is where I was saying in step 3, I get stuck. I don't know what b is. So it's valuable for me to use that point, that b value, where this is going to be my x, the 2, and this is going to be my y. So I'm going to plug in point b for x and y. So you're going to see now this is going to be negative 3 for y, and then my slope is negative 1/2. I'm timesing it by whatever my x value is, which it looks like 2. And voila. Negative 1/2 times 2, what's that? Mm-hmm.
You could cross multiply, so 2 over 1.
Mm-hmm.
Yeah, so you go negative 1 over 2 times 2 over 1.
Mm-hmm. Okay.
And then you multiply 2 by the 2 and the 1 by the 1. But I don't know what happens to the negative.
Oh, remember when we did it like the other day when we said this times the numerator and then just divide by the denominator? So this is like 2 times -1, -2, and then -2 divided by 2?
One.
-1. What's last? What's last? Nolan, you good? Peeps in the back. You good? What do we do now with B? I want B by itself.
It's not done?
It's not done. I need B by itself. That -1's like crimping the vibe. How do I get rid of it?
Oh, -1, -3, minus -1.
Still on that.
Okay, which minus -1?
No.
That's like +1. Right? I'm just bringing it over and changing sign. Exactly, which that's just gonna give me -2. Right, so therefore we can say y equals my slope -1/2 x, and then my y-intercept -2 is the perpendicular line. I'm waiting. What's up? That's okay, I'm gonna zoom out. So it was the same steps as like the parallel line. We only had one little extra thing which was I had to flip the slope. That was it. Yep.
Just for the part where it's like the -1 over 2 times 2,
Mhm.
You multiply it by -1 or positive,
-1.
and then you divide it by -2.
Divide by just 2.
Could you
Because the
do-
negative's there. Are you saying you can do the flip, like times by +1, divide by -2?
Yeah, could you-
You'll get the same answer.
Okay.
Yes.
Can you zoom in on number 4?
So that's all. We just said 2 times -1 is -2, and then divide by 2 is -1. So they're the same. They're very similar, just perpendicular lines. You've got that one little extra step.
Miss Embry, can I have help for 7?
We're gonna do it together. Don't worry. Okay. Am I okay to scooch down to this one? Okay. Y'all, this is the last example, so I need you to like lock in and focus, because I hear all little different chit chats across the room, right? You'll miss this, and then you'll be like, I don't remember her teaching it, right? So last bit is like, okay, we're combining what we know about lines to graph not 1, but 2 lines, right? So we have to graph these 2 lines and then find where are they intersecting, aka where are they crossing, right? So again, I've got one that's already in y equals mx plus b form, that first one, but the second one you'll see it's not quite there. I've got 2y. I just want y.
Oh, got it.
I know. So even if you use your colors to say like, okay, I'm gonna do this one in blue and this one in pink. The first one, the only thing you really need to do is like, you could rearrange it to put the slope first, have it like y equals mx plus b instead of b plus mx, which what's my slope here? What's my slope for blue? -3, exactly. So your rise over run is gonna be, since it's a whole number, you're going down 3 and then over 1, right? Whole numbers, they're not like fractions in the sense where they got something in the denominator, so we just have to put a 1 there. Right? What about my y-intercept? Where's my starting point for this?
5.
What, 5?
5, exactly. This is your 5. This is your y-intercept. It's okay. I'm just gonna go straight into graphing this one of like, okay, here's my 5. I know this is my starting point. And then this line is negative. It's decreasing, hence the -3. So I'm going down 3 over 1. Right? Down 3 over 1. And I'm gonna just keep repeating until I run out of room. And you'll see, okay, that's about enough. It's okay. This is my line. It's okay. There's my point. Was this okay, plotting it and doing rise over run?
Yeah.
Coolio. The second one, you see, it's kind of close to y equals mx plus b, but I've got that coefficient in front, which I do not like at all. I need it to just be y. So how do I get rid of that 2?
Divide.
I gotta divide it out, exactly. So everything's getting divided by 2. So okay, in this case, I'm gonna be left with, okay, 4 over 2. What does that simplify to?
2.
Just 2, so 2x. And then this one, you'll notice it's a little uglier. Negative 5 over 2. 5 isn't divisible by 2. So you could leave it as a fraction, as just negative 5 over 2. Or if you go to plug that into your calculator, you could write it as a decimal, which this is going to be minus 2.5. Which I think sometimes in grade 10, using a decimal is a little easier to plot. Like, for example, if I said plot 5 over 2, you might be like, I have no clue where that is. Versus if I told you to plot 2.5, you'd be like, oh, I know where 2.5 is. Right? And that's exactly what we're going to do. We're going to go and plot. So, okay, I see that my starting point is going to be what? What's my B for pink?
B is gonna be -5.
This is for pink. Negative 2.5. And then your slope, or your rise over run, is just 2. It's okay, I'm going to negative 2.5, which is like about here, right? It's in the middle between 2 and 3. And I'm going to go up 2, so 1, 2. And then I'm going to go over 1. That's my next point. And I'm going to do the same thing. Up 2 over 1. Up 2 over 1. Right? Up 2 over 1. So you'll see we're never on like a really nice point. We're always on like these half points. I'm going to draw. Voila. Was that one okay to draw? And we know why we went that direction versus the blue direction.
Yeah.
Yeah? Okay. So now I gotta zoom in and be like, where did I intersect? Where did I cross? Which if I draw or erase these squiggly lines, maybe it's a little less overload. It looks like I kind of crossed here. Which, how could you read that as a coordinate point? What coordinate point does that look like? I agree, 1.5, because if this is 1, then this has to be 1.5. And then it looks like I haven't quite hit 1 yet, so this is 0.5. Voila. That is your point of intersection. You could prove it by then plugging in 1.5 for x into each equation and seeing if it gives you 0.5. So that's your way of like verifying and checking. But in this case, it is 1.5, 0.5, right? So this stuff is very helpful for Unit 1 because we're going to be jumping in here into linear systems, lines intersecting, and how to not only determine it graphically, but also algebraically, right? So there's ways to do it without graphing and how to tell. So we're going to jump into those things. So I'd be super confident with this since this is our first lesson of grade 10. So this time is yours. We've got about like...
Wait, can you zoom
Yeah?
in on step 1 for 6, just so I can finish copying it?
Yes.
Okay, thank
So we've got about like 35 minutes before lunch, so you've got some time for some practicing graphing questions and going into parallel lines and perpendicular lines. Is there anything from yesterday's lesson that you want to do together? From any homework? No? No? Okay, if there's something that comes up, you let me know.